Good morning, friends. In today's presentation, we are going to see deep learning in information storage and retrieval, that is our ISR. In next slide, we are going to see what is deep learning. Deep learning is basically a subset of machine learning that uses neural network to stimulate the human brain abilities to learn and make decisions. It involves the training of large neural networks with multi-layers to abstract high level of raw data. Deep learning has achieved a remarkable success in various domains such as computer vision, natural language processing, and speech recognition, and various etc. domains. So, the next slide represents how what were the challenges faced by the traditional method. So, in traditional methods, there were a lot of struggle in maintaining unstructured data such as images, videos, text document. Deep learning has provided a remarkable success in solving these problems by providing efficient storage and retrieval of unstructured data. It can automatically learn representation of data that capture meaningful pattern and relationship, making it easier to organize and search large volume of information. So, how deep learning can be used for information retrieval? Deep, deep learning algorithms can be applied to enhance information retrieval systems by leveraging neural networks. We can improve search accuracy and relevance by understanding the concept, context, and semantics of users' queries. Deep learning models can also analyze user behavior and preferences to provide personalized recommendations and enhance the overall user experience in the search and etc. various purposes. So, moving toward the next slide, we are going to see what are the benefits of deep learning in ISR. So, the first one is improved accuracy. Deep learning models such as convolution neural network and recurrent neural networks, that is RNNs, can significantly improve the accuracy of context classifying the information retrieval tasks. They can learn complex patterns in data, making them efficient for tasks like image and text recognition. The second one is semantic understanding. Deep learning models can extract semantic meaningful from data. This is particularly useful in natural language processing tasks, where they can understand the concept, context, and meaning of text, allowing for more relevant documents retrieval and context recommendation. The third one is personalization. Deep learning enables personalized context recommendation based on the user preferences and behavior. Recommendation systems can analyze a user's historical interactions and provide tailored context suggestions, improved user experiences. The fourth one is efficient search. Deep learning can enhance search engines by improving the relevance of search results. It can understand the user's queries and match it with relevant documents or objects more accurately, reducing relevant searches, irrelevant searches. Fifth one is handling unstructured data. Deep learning is adequate at handling unstructured data such as images, audios, and unformatted text. This is crucial for modern information storage and retrieval that deals with variety of data types. And sixth one is automation. Deep learning can automate many information retrieval tasks, reducing the need of manual categorization and tagging, making the process more efficient. Seventh one is anomaly detection. Deep learning can be used to identify unusual patterns or anomalies in data, which is efficient for storage and fraud detection in modern technologies and retrieval systems. Overall, deep learning's ability to handle complex data, provide accurate and personalized results and adequate to changing needs, making it valuable technology in the field of information storage and retrieval. Moving towards the next slide, what are the challenges in deep learning in ISR? So the first one is data quality and quantity. Deep learning models require large amount of high quality labeled data for training. Obtaining and accurating such datasets can be costlier and time consuming, particularly for niche or specialized domains. Second one is overfitting. Learning models are proven to be overfitting, meaning that they may perform well on the training dataset but realize poorly to unseen data. Techniques like regularizations or cross-validations are needed to mitigate these issues. Third one is interpretability. Deep learning models are often considered as black boxes due to their complex architectures. Understanding why the models make specific decisions or reliable retrieval can be challenging, where is problematic in applications where interoperability is essential. Fourth challenge is computational resources. Training deep learning challenges modern require training training deep learning models require significant computational power including GPUs and TPUs. They can be expensive and limit the accessibilities of deep learning in resource constrained environment. The fifth challenge is ethical concerns. Deep learning models can essentially reinforce bias present in training data, leading to biased recommendations or search results. Addressing these ethical concerns and ensuring fairness in the critical challenges is very difficult. Sixth challenge is security and privacy. Deep learning models may be vulnerable to adversaarial attacks where malicious actors manipulate input data to diverge the model. Additionally, in securing the privacy of user is a concern, especially when dealing with sensitive information. Seventh challenge is about long training time. Training deep learning models can take a long time, especially for large networks and massive data sets. This can render real-time or near real-time applications. So moving towards the future scope of deep learning in ISR. The future scope of deep learning in ISR is incredibly promising in wide with several existing development anticipates. Deep learning models are expected to evolve in a way that enables more adequate semantic understanding of various data types including text, images and audio. This will lead to significant improved accuracy in information retrieval as these models may, may more adequate at grasping the context and meaning of context. The multimodal retrieval where deep learning models can seamlessly integrate and search across different data modalities is expected to become more relevant. This will open up the new possibilities for comprehensive and holistic information retrieval experiences. Additionally, personalization where is a central focus where recommendation systems become increasingly accurate and dynamic as they adequate to individual user preferences in a real-time transfer learning will be a prioritable role, allowing pre-trained deep learning models to be fine and tuned for specific ISR tasks. This will reduce the need of extensive label data, predicting the development of models in various applications. Efficiency in search engines will continue to improve as a deep learning model become more proficient at understanding complex queries and retrieving results rapidly, even for niche and specialized topics. This is crucial for enhancing user experience, particularly in scenarios where timely access to information is essential. Privacy preservation will remain a significant concern and future of deep learning techniques will likely focus on ensuring our user privacy while delivering relevant results. Techniques such as federated learning or homomorphic encryptions will be explored to strive a balance between personalized recommendations and privacy protection. So, real world application of DL in ISR are very much interesting. Deep learning is already been successful in applied in various real world applications. Examples such as image, video recognition, voice assistant, recommendation systems, and automated document classification, and all are favorite. That is ChatGPT is also an application of deep learning. These applications demonstrate the practical impact of deep learning in improving the information storage and retrieval across different industries. So the next slide concerns about the ethical considerations. So as we all know the power of deep learning in ISR, it is essential to address the ethical considerations. Deep learning raises concerns related to privacy, bias, accountability. It is crucial to develop transparent and accountable deep learning systems that represent user privacy and mitigate biases. By addressing these ethical considerations, we can ensure the responsible and beneficial use of deep learning in ISR. So, in the last slide, I will conclude by saying that deep learning has revolutionized the information storage and retrieval, enabling efficient organization, searches, and analyzing of unstructured data. Despite challenges and future prospects of deep learning in ISR are promising, by addressing ethical concerns and advancing research, we can fully unleash the power of deep learning and continue to transform the way we store and retrieve the information. Thank you. Thank you to all.